This lab is impact testing. Impact tests are an indication of the toughness of a material. Toughness is defined as the ability of a material to absorb energy during plastic deformation. From class, you may recall that the energy a material absorbs during plastic deformation is represented by the area under a stress-strain curve. In this experiment, two samples will be tested, aluminum and steel. External conditions affect the toughness of a material, and in this lab, two external conditions will be varied. First, temperature will be varied amongst the samples between hot, cold, and room temperature. One should find that cold temperatures tend to make a material more brittle, while hot temperatures tend to make a material more ductile. The other external condition that will be tested is geometry, specifically the geometry in which the sample will be held when it is struck by the hammer. Two machines will be used to affect this geometry, the Sharpie machine and the Izod machine. The Sharpie machine holds the sample as a simply supported beam, while the Izod machine holds the sample as a cantilever beam. Both machines operate with a large weight attached to the swing arm, which is used to perform both tests. The potential energy of the weight just before and after impact is calculated. The difference in these two values is the amount of energy the specimen absorbed when hit. As always, one important aspect of every lab is lab safety. And in this lab, we're going to be dealing with temperature extremes, both on the cold and hot side of things. Our cold samples will be in dry ice. Therefore, make sure you use the supplied pliers and gloves when handling those samples. They will be found in the white styrofoam cup. Hot samples can be found in the furnace here and will be at a temperature of approximately 500 degrees Fahrenheit. So again, use the supplied tongs and the gloves when handling those samples. Once a sample has been removed, place it in the machine behind me and begin your test. This is the Sharpie test machine. What makes this machine unique is twofold. First off, the samples will be held as a simply supported beam, and that is one of those external conditions I mentioned earlier, the geometry of which the sample is held. Next off, we have the hammer of this machine. It is a 15-pound hammer. This hammer will be held from a height of 2 feet, which results in a total potential energy of 30 foot-pounds. Before we begin any sort of test, we have to make sure the machine and scale are zeroed. In order to do this, we must raise the hammer, and it locks into position here, again at a height of 2 feet from the center of the mass of the hammer to the sample. Next, we must push the dial all the way past the end of the scale. The end of the scale reads 30, and again that's because the total potential energy for the Sharpie machine is 30 foot-pounds. With the dial placed past the end of the scale and the apparatus clear of any people, we can push the handle towards the wall with no sample in place to zero the machine. Catching the hammer and releasing it slowly back to the down position, we can see that the scale has returned almost all of our potential energy, which makes sense because there was no sample there to absorb any of that impact. Looking at where the scale stopped, that is our new 0 point, and all of our measurements from the future should be taken from that 0 point rather than the actual physical zero of the scale. Now that we have zeroed the machine, we're ready to begin our first test. To do that, we need two things. First off, the sample for the Sharpie machine. This is the shorter of the two samples, as the Izod sample is much longer. Next, we need the jig. This jig will help us accurately mount the sample into the Sharpie test machine. Sliding the jig from the left side to the right, it will lock into place. Taking the sample with the notch that's in the sample, facing the peg in the jig, align the two, pushing the sample firmly up against the Sharpie machine. Removing the test jig, the sample is now properly aligned to begin our first test. With the sample now mounted, we're ready to begin the test. Again, remember to make sure that the dial here is past the end of the scale so that we get an accurate reading. Also, double check to make sure there's nothing in the way of the swinging pendulum as it comes down, otherwise it'll ruin the results of the experiment. With everything ready to go, we'll push the handle towards the wall and begin the first test. Catching the hammer on the return swing and slowly bringing it down to its neutral position, we can go ahead and take our reading, seen here on the scale, from the 0 point that we measured earlier. Once you have completed testing a hot, cold, and room temperature sample of both aluminum and steel in the Sharpie test machine, you can move on to the IZOD test machine to test those same materials at those temperatures. The IZOD machine is unique for two reasons. One, the geometry in which it supports the material is a cantilever beam as opposed to the Sharpie's simply supported beam. Also, the weight of the hammer is 30 pounds. So again, the hammer is held from a height of 2 feet. This results in a potential energy, 2 feet times 30 pounds, 60 foot-pounds. This doubles the potential energy capable in this machine. Again, we need to make sure that the dial is zeroed on the IZOD test machine. To do this, we're going to raise the hammer, locking it into its final height of 2 feet. We will push the dial past the end of the scale, and on this scale, the number reads 60 for that total potential energy of 60 foot-pounds, and we will run our test. Pushing, again, the lever towards the wall, the hammer swings through and will slowly catch and release it back to its neutral position. Now, the reading on the scale, that will be our new 0 point from which we can measure all of our future experiments from. Now that we've zeroed the test machine, we're ready to begin our first test on the IZOD machine. First, we need the IZOD test sample. These are the longer of the two samples, and this will be used, again, in both aluminum and steel specimens at the 3 different temperatures. We also need the jig. The jig, just like we had in the Sharpie machine, will help us align the sample so it's struck at exactly the right point. This jig gets left in during the entire experiment and does not need to be removed. Placing the jig from right to left into the machine and the sample down into the hole, we align the jig with the notch in the sample until they're firmly locked into place. And now we're ready to begin our first test. With the sample now in place, we can begin our first test. We want to make sure that dial is again past the end of the scale and that there are no obstacles in the way of the hammer. With this ready to go, we can push the handle towards the wall. Catch it on the upswing and lock it back into place. And on the dial here, we can take our reading for the amount of energy absorbed. With the experiments now complete, you should have run 12 full tests, 6 on the Sharpie test machine and 6 on the IZOD test machine. You're going to have a lot of broken samples laying on the floor, so make sure you clean them up as a courtesy to your classmates.